Today we start Learning Target 2, and Learning Target 2 deals with prime and composite numbers and prime factorization. Today we're looking at deciphering the difference between prime and composite numbers and looking at divisibility. So first thing we want to review is what a prime number is, because a lot of you have a hard time remembering this when you first learned it in 6th grade. A prime number is a number that is only divisible by 1 and itself. Now, on the other hand, if it's not prime, it's usually composite, which would be a number that is divisible by more than just 1 and itself. And when we talk about this concept of divisibility, divisibility, or being divisible, is capable of being divided or broken apart. So knowing that, we want to go ahead and take a look at some options for prime versus composite. So in order to do that, we need to know our divisibility rules. So I'm thinking here, if it's divisible by 2, I know it's an even number. Therefore, it ends in 0, 2, 4, 6, or 8. So I can just look at that number and tell if it's divisible by 2. Now when it comes to 3, 3 is a little bit trickier. For 3, we want to take the digits of the number and add them up, and if it's divisible by 3, then the whole number is divisible by 3. For example, I know that 99 is divisible by 3 because if I take 9 plus 9, I get 18, and 18 is divisible by 3. For the number 4, the last 2 digits of the number is divisible by 4. And some of you might be wondering, well, what if it is a 2-digit number? Well, you should be able to tell. The other way I look at it is if you can divide the number in half and the answer you get is an even number, then you know that the whole number is divisible by 4 because that's like dividing by 2 twice. For 5, if it ends in a 0 or 5, so 5, 10, 15, 20, notice they bounce from 0 to 5 for that last digit. Therefore, it makes it divisible by 5. 6 is an easy one if you're going in order, because if it's divisible by both 2 and 3, then it's divisible by 6. 9 is similar to 3 in that the sum of the digits, when you add them together, gives you a number divisible by 9, then it's divisible by 9 itself. For 10, it has to end in 0. Pretty common sense. Now, some of you might be noticing we didn't do 7 or 8. 7 is a very complicated rule, so rather than giving it to you, I'm saying if I want to know if it's divisible by 7, go ahead and divide it by 7 and see what you get. 8, if you can divide it by 2 and it gives you an even number, and then you divide it again by 2 and it gives you another even number, then it's divisible by 8. But we aren't going to worry about 8 because that's not a picky one. So I want to take a look at these 3 ones I have down here. I have 57, I have 247, and I have 1495. 57, a lot of people want to say is prime, but if you actually take the 5 and the 7 and you add them together, 5 plus 7 is 12. 12 is divisible by 3. So therefore, this is composite. $247. Well, it doesn't end in 0, 2, 4, 6, or 8. If I take 2 plus 4, I get 6, plus 7 is 13. That's not divisible by 3. It's not divisible by 9. It doesn't end in 0 or 5. And if it's not divisible by 2 or 3, it's not divisible by 6. And it's an odd one, so it's not divisible by 4. Therefore, that makes this prime. Now, 1495. I look at it, it ends in a 5. I know it's divisible by 5, therefore making it composite. And I remember it this way because a composite sketch has many parts to it. Now, the next piece we need to take a look at is you need to give it a shot of trying these numbers of what are all the primes between 1 and 100, and is the number 1 prime or is it composite? And I want you to take a look at that for tomorrow.